Outside of these memory accesses runtime errors that I described last week, Rust also has undefined behaviors. What is special about them is that they can only occur in code that you highlighted as unsafe. Why even do this? Here are 3 examples of why people would choose to make a code block unsafe. So first of all, reading or writing inside hardware. The value that you're going to be finding in there is unpredictable, and it's always going to be changing. It's like volatile in C, right? So you never know if you're going to read at time 1 and time 2, whether there's some other process that is basically hardware based that is going to come in and change the value. Now, that's why it's unsafe, but it's also necessary to be unsafe. Second case is when you interface Rust code with C and C++ code. And that is probably going to happen very often because there's a significant legacy investment into these code bases and it will need to be reused. Now, each and every time that this happens, it can become a source of runtime errors for the overall program, even if it originates from the C and C++ side. And finally, in some circumstances, a code may be declared unsafe by the developer for performance reasons. There is a cost of programming something that can be considered safe. And sometimes, well, unfortunately, that cost is too expensive. And then, unfortunately, choices need to be made. Now, all of that unsafe code can cause runtime errors. And here's a kicker. Sometimes the symptom of that runtime error is going to be experienced immediately, or just as in C and C++, it could be actually experienced later on during the execution process. And debugging these, now that can be very difficult and challenging. Now, the good news here is that formal methods that you can be using right now to detect and pinpoint the source of runtime errors in C and C++ can be actually used within the Rust world as well. But here's an even better news. Some tools will let you analyze both Rust alongside C and C++ code. So in one analysis, you can actually detect and pinpoint these pesky runtime errors at their source, whether that code has been written in Rust or in C and C++. One project, one code base, one analysis. If you happen to be a bit curious about this and you happen to be at Embedded World this week, swing by our booth, hall number 4340. Ask for Roland or Guillermo and they will be able to explain to you in detail how this is all working.